flashing screens late at night, circuits humming in neon flight. Every line a spark, a story untold.
Welcome back to the Quantum Computing Day 3. Today, we are going to discuss one of the most mysterious and fascinating concepts of quantum mechanics, which is quantum entanglement. Imagine two qubits, no matter how far apart they are, connected in such a way that measuring one of them immediately influence the another one, and this is the magic and mystery of the entanglement. Quantum entanglement happens when two or more qubits share a state so deeply that they can no longer define as independent. Instead, they exist as one combined system. If you measure one qubit, then the outcome determines the state of another one. And the magical thing is, this phenomenon can happen even across the galaxies. Think of it like two perfectly synchronized dice. No matter how far apart they are, when you are rolling one of them, the second the another dice automatically lands with the matching result. Even Einstein was puzzled with this. He called the entanglement a spooky action at a distance. Why spooky? Because it seems to break the rule of basic space and time, where information appears to transfer faster than light. But is it really happen like entanglement allowing information to travel faster than light? While we know that entanglement doesn't allow faster than the light communication, but it does create a correlation that classical physics cannot explain. So, why is entanglement so important in quantum computing? Basically, entanglement allows qubits to work together in such a way that a classical bits never could. Entangled qubits produce correlated results instantly. This means a quantum computer can explore massive possibilities in parallel, unlocking the potential to solve problems which a classical computer can take centuries to resolve. Now, let's look into some of the applications which is using entanglement. The first one is quantum teleportation, one of the major application of quantum technology. Here we are transferring the state of one qubit from one place to another without moving the particle itself. The next one is quantum key distribution, where we are creating unbreakable cryptographic keys. If anyone trying to intercept these keys, the entanglement breaks and we know immediately. The third is Superdense coding, where we are sending two of the classical bit of information by using just one qubit. Each of these shows how entanglement revolutionized the communication, security, and data transfer. And there are many more benefits of entanglement, which we'll discuss in our next session. To recap, entanglements links two qubits in such a way that defeat classical logics. It's the engine behind many of the quantum applications and a cornerstone that what makes quantum computers so powerful. In our next lesson of day 4, we will do a deep dive into quantum gates, a building block of quantum circuits.
Hope you enjoyed this video. If you have any query or suggestion regarding this, please leave it in the comment section. You can also find me over my Twitter handle @AVI Tech Support. Also, please don't forget to like and subscribe this channel and press the bell icon to get regular updates. Thank you so much again to being with me, and see you in the next video.